All right, so with that, let's go ahead and get started. I'm taking a look at some of your reasons for being here. This is great. I'm glad you invited some brand new people, Joey. I hope we see them. Thanks, Joe, for forming part of a community. This is great. All right, so today's topic, based on a survey that I handed out via Slack and via email, is that people wanted to know a little bit more about Python notebooks for data analysis, as well as data ingestion. And so I sort of was on the fence about how deep to go into various types of data ingestion. So what I decided to do was leave aside for now things like images and text, and maybe let that be a separate session. And today concentrate on bringing in specifically two types of rectangular data: comma-separated values, or CSVs, and fixed with format files. And along the way, we will also be talking about APIs, we'll be talking about notebooks, and also where you can do Python at CHOP. So as I said, my name is Joy Payton, and I use she, her pronouns. And my New Year's resolution is to contribute to the renewal of this Python user group community. I've sort of let it lapse, and I really want to encourage it to come back to life. And for that, I need your help. So please tell your friends, tell your colleagues to join us. I would love it if you would be willing to present something that you're working on. My personal jam with Python is data analysis. Maybe you like to build websites with Django, or you're doing something with robotics or computer vision. I think it would be great to see what people are working on, and you do not have to be an expert. This is an opportunity for anyone who feels like they'd like to share what they're working on, get some feedback, and maybe help out people who are a couple of steps behind them. You don't have to have done this for 5 years to be able to present. All levels are welcome. And also, please join our Slack community. If you are not already part of Slack, it is a useful place to ask questions of one another. And the more people we have on Slack and the more participation, the richer the sharing is and the richer the resources are there. So please join our Slack community. Our itinerary for our talk today: where can you write Python at CHOP? So you want to get started maybe for the very first time using Python, and you don't know what to download or how to get started. Why to use notebooks for data analysis. How to ingest data. We're going to bring in a CSV from a Socrata API, and we're going to bring in some fixed with format data from Noah. And finally, I will probably close with another pitch, to be honest, to come present at the Python user group. Please feel free to come off mute. I am looking at chat. I only have so many monitors, so I can't see your faces. So if you raise your hand on camera, I won't see you. So please just come off mute or drop something in chat, and that's what I can look at. So where to write Python? And I'm going to have a slide on each of these. So one of the best places to write Python is actually within your Google Drive. And I know that not everyone at CHOP has access to Google Drive for security reasons, right? This is a change that happened recently. Now, I, and many of you, are members of the Research Institute, and we have access to CHOP's Google Drive. So CHOP has an arrangement, a business associate agreement with Google. So we have a CHOP branded, CHOP approved, HIPAA covered Google Drive, essentially. So Google Drive, Google Docs, slideshows, and one of the things that is included with that is Google Colab Notebooks. So I will be working today in a Google Colab Notebook, and you can use this if you have a CHOP Google Drive account, or you can use it with your own Google Drive on your own computer or off the CHOP network, so that you're in compliance with the CHOP network rules. And that's option one. Also, another option is an Arcus training lab, a training lab or even a scientific lab. And I will briefly cover that. If you have if you have an account on ResPublica or CHOP's high performance compute cluster, that also supports Jupyter Notebooks. And then if you want to have a local installation and work on your own laptop or desktop, I always suggest the Anaconda distribution. So we'll go over each of these in turn. So if you go to colab.research.google.com, that will take you to Google Colab Notebooks. And the benefits of Colab Notebooks is that there's nothing to download. You are running Python on a Google computer, and it's convenient for sharing broadly because you share from your Colab notebook the same way you do from a Google Doc or a Google slideshow. So you can, for instance, I can share with anyone at CHOP. I can share with only certain people. I can share with anyone in the world. I can share with only people who have the link, etc. So there's multiple ways to share this, and it's great just for passing scripts back and forth, pardon me, and working as a distributed team. Pardon me. One thing I will say, CHOP, as I said, does have a BAA with Google for Google Drive. And I checked today to see if anything had changed in what is considered HIPAA covered. So slides are HIPAA covered, docs are HIPAA covered. I do not see Colab notebooks being HIPAA covered. And I need to double check this, but I would assume for now that you should not put PHI in a Colab notebook at CHOP. And if someone has better intel on that, please drop it in the chat and let us know. But that would be my caveat there. So this is a great way to get started working with Python. Arcus Labs. So if you have access to an Arcus Lab, you know who you are, and you have a URL that you are permissioned to. The nice thing about an Arcus Lab is you have a URL that you log into, and you have several tools there at your disposal. You have access to a SQL front end. You have access to RStudio. You have access to Bash scripting. You have access to Jupyter Lab. And Jupyter Lab has kernels so that you can run Jupyter Notebooks, you can run R, you can run Julia if you're using Julia already. So there's a lot of options there. And if we have time at the end, I might demo an Arcus Lab to give you a flavor of what's possible. CHOP also has a high-performance compute cluster. So this is used for applications that are massively parallelized or have really big memory requirements or constraints. And so we have an HPC cluster, which is called ResPublica. And again, if you use ResPublica, you know exactly what I'm talking about. The nice thing is you can go to the URL right there, and you can see that there you can spin up your own Jupyter Notebooks machine. In fact, I'm just going to do this. Let's see if I can. All right, so here I am in ResPublica. It allows me to choose the job profile that I want, which is great because if I know that I'm doing a notebook that has really big memory needs, or you know, I need some sort of, like I need a GPU, I can choose that. In my case, I just want the very basic, so I'm going to spawn that. Oh, sorry, I'm pending. All right, all right. Let me log out and log back in case I... These are just your normal credentials. And there is my Jupyter server. So now I can say I would like a new Python 3 notebook. And in theory, they do it for me. In theory, I'll get a nice Jupyter notebook. Of course, this is a live demo, so it's not being as nimble as I would hope, but it is spawning my own machine, and eventually I will get a notebook available to me. And you can see that this saves documents right in my what Windows users I think at Shop call our H drive, and for me as a Mac user is sort of my personal drive. So it will by default save things, and you can see I have a few notebooks here that I've been working on. And there you go. This is what it looks like. So I can add a new cell and start my Jupyter notebook. So that's using the HPC. Finally, if you want to download Python on your own machine, I strongly recommend the Anaconda distribution, because Python is it's like a multi-tool. It's like a Swiss Army knife, and it does a lot of different things, which means there's a number of ways to program in Python. But if you're doing data analytics, the Anaconda distribution or set of software includes the basic tool set that you need, so that you're not constantly having to install the standard packages over and over again as you discover, oh, this is standard operating procedure. Everyone uses this library. Anaconda comes packaged with everything you need to start doing data analytics. And it's a free download. So if you have access to download and install software on your own computer, go for it. If you don't, you might have to file an IS request to get this installed, but the Anaconda distribution is what I recommend. So any questions from that? I'm going to take a peek at your faces, those of you who are on camera, and see if there's any questions about where to get access to Python at CHOP. All right, if not, we can jump right into code. So this, as I said, is going to be a Colab notebook, so it is going to be in Google. Not everyone may be able to look at this right now, depending on if you're on the CHOP network and if you're part of the Research Institute or not. But I will share this URL in the chat so that you have it. I always recommend doing data analytics within the framework of a Python notebook. And this is a Python notebook. And if you're used to doing Jupyter notebooks through Jupyter Lab or just plain Jupyter notebooks, what we used to call IPython notebooks, it looks a little bit different, but this the idioms should translate pretty well. That there's two kinds of cells. There are code cells and there are text or markdown cells. And what we are trying to accomplish when we write a notebook is interweave three things. We want to combine our statistical or scientific reasoning. Why are we doing a thing? Why are we asking a certain question or looking at certain data? So describing it in human language, in well-formatted language that's easy to read. It has things like headers or bulleted lists, something like that, that makes it easy to read and easy on the eyes. You also are interweaving the code that's trying to accomplish what your scientific reasoning pointed out, and then the output of your code, if there is output to that code that you have run. And so this gives a full story. I call this writing your methods section. So you are at one and the same time documenting your methods and executing your data analysis. And if you do this part well, number one, you're going to be really close to what you need for a methods section in a publication, or describing something to a senior stakeholder, or whatever the explanatory piece may be. And you're also making things easier for future you. And I know somebody on this call probably knows who said this. I don't remember the original author, but it's something like metadata is a love note to your future self. And I would say documentation and writing good literate statistical programming is also a love letter to your future self, and you'll be glad that you did it. So you will see here that this is a text cell, or it contains markdown. And so if I double click on this, you can see that what I actually typed here was a hash mark, which creates a header. I put some backticks around the word pandas, and that makes it look monospaced. And I included a link here, which automatically renders as a link. So by using some symbols here, I use Markdown to say I would like my text to be formatted in a certain way, and indeed it is. If you are new to Markdown or you're new to notebooks, I really recommend that you follow this link, because I'm not going to go into any more detail about sort of the purpose of a notebook or how to write Markdown, because that's something that's pretty easy to pick up on your own, and I know that a lot of you on this call already have those skills. But this notebook is one written by the Google Collaboratory, I guess, group or committee, and it describes really well the point of notebooks, how to use them effectively, and how to write good Markdown. And then we have code cells like this one, and you can see the code cell has a play button, and in this case we're going to import pandas, but anyway, I'm trustworthy. So you can see it's running, all right, and now it's run. Now in this case, this cell has no output, and that is as expected. And the first thing we're going to do is work on bringing in comma-separated values files. Now, you could get CSVs or comma-separated values files from a number of sources. Probably the most common is an Excel spreadsheet that you save as a CSV. So you can save a single worksheet from a Microsoft Excel workbook and save that as a CSV. Another place you might get CSVs from is, for instance, from REDCap. Maybe you'll download some data from REDCap as a CSV. And a lot of data just out on the web is already in CSV format. So in our case, we're going to use a CSV that's out on the web. We're going to use something from the CDC, ever useful and important in our lives, the CDC. And so I'm interested in life expectancy at birth by census tract. So I would like to look at Pennsylvania census tract by census tract, let's say, and do some research on life expectancy. And there's more information about this data set here. Now, behind the scenes, as you can see, this is a comma-separated values file, or a CSV, right? But this is sort of a special case of a CSV because it is an API, or application programming interface, that's serving up this CSV. And I've heard people say, what's an API? I hear people say API, I'm not sure what that is. So I thought this would be a great place to sort of throw in a little API education. So an API is simply a way for two computers to talk to each other in a predictable, regulated way. So messages between these computers follow a certain formula that is agreed upon. And different APIs use sort of different formats in different languages. But one very common API is what's called the Socrata Open Data API, or SODA. And this is on a lot of public data websites. So government websites, city, state, municipality, country websites. Socrata is a company that does a lot of public data, so the SODA API is one that might be really interesting for you if you are in the public health space, you're looking at public data, anything that a government might gather. And in this case, the CDC does in fact use the Socrata API. So I'm going to click on this description page here, which will tell us more about this data set, which again is life expectancy by census tract. And if you are accustomed to looking at public data, PA data, US data, cities, counties, this sort of layout is probably pretty familiar to you. And you can see over here, there's an API button. And that's where I'm going to get a link here. And I don't want JSON, I'd like a CSV. And that's where I get that endpoint. So that's where I get the URL that I put here. So I'm just going to pull that in, life expectancy. I'm going to use the pandas read CSV function, and then I'd like to look at the first few rows of life expectancy, and that I accomplish with the method head. All right, so it seems like we start with Alabama. Not surprising. Looks like it's in alphabetical order. Perfect. But in this case, we really only want Pennsylvania data. We're not particularly interested in Alabama. So let's just take a look at all of our state names, make sure that Pennsylvania is there. Huh, Pennsylvania is not there. It just seems like it's Alabama. And so what's going on here? I could even, let's make a new cell. Let's look at the last few rows. We looked at the first few rows of life expectancy. Let's look at life expectancy, the last few rows. It's still all Alabama. And what's interesting is it goes up to 999. And when you consider that Python starts counting from 0, this is 1,000. So this is an example of a specific API's behavior, is that this API will only give you 1,000 rows unless you state otherwise explicitly. This isn't true of all APIs, but it's true of this API. And its intent is to protect you so that you don't accidentally overwhelm yourself by downloading 5 million rows when you really only wanted 50. So in this case, what we're going to do is add on, and this is just from reading the documentation about the API. We're going to add on another parameter here called $limit. We're going to say, give us 100,000 rows, because I think that'll get us just about everybody. All right, let's see. So I'm going to ingest that from this new URL that just has that $limit. And when I look at the values for each state name, we can see we've got a much broader, it's not just Alabama. Now we have lots of states. And again, the Socrata API has other simple filters. So it will allow you to do something almost SQL-like in that you can set a column name to be a certain value. And so in this case, I honestly only want Pennsylvania. I don't want to sort through all these other states. If I could just download Pennsylvania by itself, that would be optimal. So in this case, I can do that with the Socrata API by using state name equals Pennsylvania. And I'm going to keep that limit just in case Pennsylvania has more tracks than I think. Stop at 100,000. So let's do that. And now we have, it looks like all Pennsylvania all the way down. Perfect. And I said, show me the first 100. So it says, all right, here's the first few and here's the last few of those 100 rows. And so the nice thing about pandas, which we conventionally abbreviate with PD, is it has these very smart helper functions, right? Like read CSV. And if your CSV is formatted in this sort of typical way, which is it's comma separated, which is what CS in CSV means. So the fields are separated by commas, and there's a header row with column names. And any text that might sort of accidentally have a comma in it is enclosed in quotes to indicate, no, this is a text that has a comma in it. It's not intended to be a separator. If those three things are true, comma separated, quote delimited, and header row, you don't need to add anything else. And I would say 95% of CSVs will fulfill those three criteria. And so you can just do that read CSV or read underscore CSV, and you'll get your data in an object, a data frame very easily. So I'm going to pause there before we go on to fixed width, because fixed width is going to be a little bit more challenging. So just pause here for any questions. All right, let me just check chat. Is reading an Excel file about the same? That's a great question, Joey. I would say, first of all, I personally seldom work with Excel files, so I will confess that I am not the expert in reading Excel files. The issue with reading Excel files is you need to indicate which sheet you're pulling from, because generally in a workbook, you may have multiple sheets. And the other challenge with Excel spreadsheets is that often there is information encoded in a way that Python can't pick up on. For example, if one of the ways you encode data is by marking good values in green text and bad values or outlier values in red text, that is not a method of annotating data that Python will be able to automatically detect. So a lot of it depends on how you and your team uses Excel. I do have some great articles sort of that I've been reading lately by Carl Broman. Oh gosh, and what's her name? Kara Wu, about using Excel responsibly in research. And one of the things that they emphasize is having a tidy data format, if you're used to thinking about tidy data from the Hadley Wickham article, but also avoiding things like using color coding or highlighting. Or another thing that sometimes happens in Excel spreadsheets is someone will merge 7 cells and put a little note in there and say, this is from X time to Y time and does not include. So some explanatory cells, and that can be very confusing as well for data ingest. So I would say with Excel spreadsheets, your mileage may vary. I personally prefer to take an Excel spreadsheet, save what I want to a CSV, and then use it from there. Oh yeah, conditional formatting. Rich points out formulas. Like there's a lot of things in Excel spreadsheets that just don't play well with sort of modern data analytics. But Pandas does have a read Excel method. I just honestly don't use it that much. All right, now let's jump into fixed width. So fixed width format, this is something you'll see a lot with government data. NOAA is the common source that people use in examples, and it's the source that I'm going to use here. Fixed width format goes back many, many decades in early computer systems. So, and you still see it today. So you may run across fixed width, and this can be challenging for a number of reasons. It is not as rigorously defined as other formats. So my fixed width format and your fixed width format may be very different. I may use spaces to between values. You may want to fill it with dashes. You may have 2 header rows. I may have 1. You may have 0. There's a number of differences across fixed width format. And a lot of times in fixed width format, there may be a few rows at the top that are metadata that explain something about the file. And then after that comes the data itself. So how do you skip past that metadata and then get into the data itself? And this is, again, where Pandas methods are going to be super useful to you, especially read fixed width format. So in this case, I just pulled some information from NOAA, and this is the description. I think it's going to download it actually because it's an FTP. Right. I think I might have this already, actually. Yes, I do. All right, so this is that file. So this file here in black, this is the description from that ends in readme.txt. So this describes lots of different kinds of files. And the file that we're going to look at is an inventory file. So I'm going to look around. In fact, I'm just going to do a search here for inventory, because this can tell me a little bit of what to expect. Format of the inventory. All right, so I expect to see an ID, and it tells me which columns they're in and what the type is, lat, long, the element that's being measured, the first year and the last year. So it gives me a lot of metadata here. Fantastic. Well, let's actually look at this inventory. I will show you what this inventory itself looks like. So this is the inventory. There is no header row. So to get any sort of metadata or understanding what these columns are, I have to kind of go back here and say, oh, right. The first row, the first column here is ID, and then there's latitude, so latitude 17 point something, longitude negative 61, element T max, that's probably temperature max, temperature min, precipitation, snow, et cetera, and what's the first year and the last year that this data was collected. All right, so the nice thing is I don't see anything particularly odd about this data set. It looks pretty good. There's nothing that looks like it's broken. There's nothing to skip. So what I'm going to do is just try, and this is what I often do, is just try bringing it in with no other parameters. Let me just try read fixed with format on this without adding any other parameters and see what happens. So I'm going to pull it in and then look at it, look at the first few rows, and you can probably predict the problem that we're going to have. The problem that we're going to have is that this doesn't have a header. So it took the first row of data and presumed it was a header. And that's not quite right. So that's all right. We can go back and add a couple more parameters. So I'm just going to overwrite weather. I pulled it into weather here. I'm just going to overwrite weather. And what I'm going to do is add header equals none, and then some names. Station, lat, long, element, begin, and end. And let me run that. And then look again. And now you can see it starts with the data that we expect. When I'm working with fixed width, I always like to just pull over the file itself and just say, does that look right? Is there a minus where I expect there to be a minus, or did that get left off? All right, does this have 4 digits? Yes, it does. Great. All right, this came in really well. I didn't have to use that information about which columns were in use, because Pandas was able to auto-detect that. So that's fantastic. That's your best case scenario. And when that happens, that's great because you've saved a lot of time. But sometimes, and especially with fixed width format, you'll have some sort of hybrid file. So for instance, okay, so this is an example of a not atypical fixed width format file. So it'll have some metadata, some information at the top. Then it's got 2 rows here of headers, so sort of nested headers. And I honestly don't know what these are. I didn't look into any more detail about what this means. I'm wondering if this is like El Niños or something like that, because there's 1 and 2, and then 3. Looks like 3 and 4, and then 4. And then there's 2 values underneath this, SST and SSTA. And it may not be obvious that it's 2 values, right? Because they're kind of stuck together. So the first time I saw this, I thought this was a range. I'm going to move back over here because I did copy the first few lines here so that we could see it in situ. So I thought this was maybe a range or a math or something, so that this is 1 value. But then I realized, wait. This isn't 1 value. That isn't a range. That isn't a math problem, a subtraction problem. That's 2 different numbers. And that's when I realized, oh, it's because I've got 2 different things here, and they're just smushed together. So the one value is 25.1, and the next value here is negative 0.3. Again, I'm not sure what these values represent, but it took a little bit of sort of wrestling with it to figure out how to do this. Now, even though this is a complex fixed width file, I still always sort of like to try just bringing it in without anything extra just to see what happens. So I call this more weather, and I'm just going to bring that in using read FWF just on that URL with no other additional parameters. And let's see what we get. And unfortunately, it is not great. So we have weekly SST, data starts, week centered, on, 3 Jan 1990. This is clearly not right. It doesn't even make sense, right? So we definitely have to do some more work here. So what do we have to do? We have to skip some lines. We have to skip this line and this break line between, and we want to actually get rid of these two header lines because understanding how to do two headers is really hard to parse. So we're better off just sort of rewriting the headers. So we're going to get rid of the first 5, I think it's 5 rows, because I think there's actually 2 rows of new lines between the metadata and the start of the headers. So we know we're going to skip some lines. We also suspect that it's not going to allow us to, it's not going to pick up on the difference here between this value and this value, because it looks like it's all one, right? Pandas is going to make the same mistake I did, which is this is all text smushed together. It's all one thing, and we know that it's not. So this is an example where we have to do a little bit more work. Oh, so it's 4, it's not 5. So I'm going to skip some rows. How many? 4. I will say, by the way, there are no headers. I will supply you with the names. Do not try and auto supply them from a header because there is none. And then I do these column specifications. And I have formatted this so that it works the first time. This is not realistic, right? Instead, what I actually did was didn't feel like counting all the way, so I sort of estimated, and then I realized I was maybe 1 or 2 too early or 1 or 2 too late, and just sort of had to play around with it because I didn't feel like counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then how many spaces, right? And I didn't bother looking up on NOAA. Maybe there's some description there, right? So exactly, Meredith, iteration happens. So I iterated on this a few times until I got these numbers right. And these are what are called column specifications. So these call specs, these are pairs of numbers that tell you the first column that a value begins in, and then the first column that it is not included in. So remember in math where you learned about like square brackets and that was inclusive and then parentheses were inclusive, or maybe it was the other way around, X and N. The important thing to remember in these pairs, and you will forget, so you're just going to run it and realize that you've lopped off some characters and then you'll correct yourself. The first number in this pair is included, and this second is not included. So what I'm saying here is take 1 to 9 and make that a value. Here I'm saying take 14 to 18 and make that a value. Take 19 to 22 and make that a value. And this is something that is very apropos to Python. If you've worked with Python a lot, you're aware of using tuples or number pairs in this way, where the first number is where you start and it's included, and the next number, the second number in the pair, is the first number that is not included, right? So up to but not including. So it's a little bit tricky to get used to. And the other thing that threw me off on this is I'm so used to starting to count from 0 because Python starts from 0. But here you can actually start from 1. So I played around with these column specifications, and it took me, I don't know, 3 or 4 tries to get it exactly right. But I kept looking at the output and tweaking. And then I also provided names. So in this case, kind of went back up and I said, well, what are my values? Well, week is clearly the first value. And then I said, well, I've got Nino 1 and 2 SST, and Nino 1 and 2 SSTA, and Nino 3 SST, and Nino 3 SSTA. So I named those values essentially using that naming convention. So if we run that, incredibly enough, almost effortlessly, it works. So what I didn't show you is some of the iteration and the flailing around, which is completely normal, especially with complex data sets like that. So that's kind of what I wanted to show you as far as CSVs and fixed width format. So we have some time for Q&A. So I will open it up to folks who have questions. Would the inverted version be used to combine data instead of separating? I'm not sure I know what you mean. Jeffrey, can you come off mute and explain? I'm sorry, I'm not quite catching the drift.
Can you hear me?
Yep.
Yeah, so for example, in this case, you separated those numbers. But what if you had, for example, let's say 1, 2, 3, and then another row you have negative 1, 2, 3, and you want to find under, let's say for this example, SST under the, what was it, Neo 1. Would you go about doing the same process, just the opposite?
Your volume went down a little bit in the middle. Are you talking about concatenating two values that are side by side?
Not concatenated, but so for example, on your line here, you have on the first line that I'm looking at. I don't know if you see what I'm looking at, but number 3, line 3. Let's just go with line 3. It has the date and it has 23.4 and then negative 0.4. Correct? Let's say that was already separated. How would I go about putting it back together? So the way it originally was, let's say I got the file already separated out with each individual row. How would I go about getting them back together to look the way
so you would want
now?
So you'd want to render
the opposite.
So you would want to get back to this because you're working with somebody at the government and they're like, no, we only know how to use fixed width. Don't give me any of that stinking CSV stuff. That's actually a really good question because I haven't made things into fixed width format. The way I would do it actually would be to paste together, I think. I would say, I would write a file and I would use some sort of paste or concatenate command to say, concatenate this value, this value, this value, this value, and that's just one row of text. And then do that, for each value. But there's got to be a right fixed width format. So this is what we're going to do. I'm going to do a new code cell. I'm going to say PD, right? Fixed width format. Let's see if there is such a thing. Oh, thank you, Meredith. See surface temperature anomaly. There we go. All right, so that didn't work. Let's do this. Pandas, right, fixed width file. So there's read to FWF. All right. So it looks like there's a few different methods that people are using. Write contents of data frame into a text file. and this is in R, right? Fixed width format. So the short answer is I'm sure there's a simple way to do it. I just have not come across the need to do it. Whoops, I didn't mean to stop sharing, sorry.
Okay. Okay, fair enough.
Other questions? Right, so as promised, I am going to close with an appeal, which is if this was useful to you or you think it might be useful to somebody that you work with, then by all means, invite them to participate in the Python user group. We have a very, very active R user group here at CHOP with a lot of participation and some great events. And I really want the same thing to happen for the Python community. So that means telling each other that this exists. Tell your peers, tell your friends, your colleagues, people you work with at CHOP and at our affiliated universities that this is available. And also, please participate as a presenter. In my case, like I said, I enjoy doing data analysis. That's sort of what I teach. Python goes a lot further than that, however, and I know that people are doing some really unique and interesting things with machine learning in Python, with computer vision, especially with anatomical segmentation, edge detection, and things like that. So there's a lot of applications for Python in medicine. So I would love to see some of our physician friends, some of our clinical quality improvement friends jump in and share what they're doing with Python, whether that's building a website or programming robots. There's certainly a lot to be learned here. If you are now a little bit less, if you find Python a little less mysterious, so you're a little bit more interested in trying Python out and maybe including it in your workday, there's lots of places to learn more. One of the places I will be a little bit self-serving here and say there's a website at education.arcus.chop.edu that has a lot of information about R, Python, SQL, about the user groups, about Arcus Labs, how to use the REDCap API in Python, how to use census data, how to do network graphs in Python. Lots of information here that you can search and work and also find your community. I think it's important sometimes to find people who are just that one step ahead of us who can save us some time. So please feel free to visit education.arcus.chop.edu. I will drop that in the chat. And if there's any other way that my team, the education team at Arcus, can be helpful to you, I would love to hear from you. I will put in the URL, education.arcus.chop.edu, and I will also drop in my email address. So please think about what you would like for a next topic. I will probably surface something on the Slack asking for suggestions and ideas, soliciting speakers, and trying to find out what would be the most useful, because your time is valuable and it's a non-renewable resource. So thank you for spending an hour of it here with us, and I will see you next time. Thank you so much, everybody.